Hello, this is the luckiest maths teacher in the world. Thank you so much for tuning into this video in which we will look at solving simultaneous equations. In particular, we'll look at using the elimination method. But firstly, what do I mean by simultaneous equations? Well, simultaneous means at the same time. What we're going to do is we're going to have two equations that we solve at the same time. So I'll start with the equations x plus y equals 5 and x minus y equals 3. So if we look at this first equation, we're not used to solving equations like this that have two variables, x and y. It turns out that this equation will have infinitely many solutions. So one possible solution is x equals 0, y equals 5. I can just write it like this. Remember, I always write x first and y second. That's a solution to this equation because if I substitute x for 0, y for 5, I get 0 plus 5 equals 5. A true statement, therefore it's a solution. There'd be heaps more. I could have x equals 5, y equals 0. That's a solution. I could have x equals 4, y equals 1. That's a solution. No need to just have positive numbers. I could have, say, x equals minus 2, y equals 7. That's another solution. And I could keep going, but you get the idea. All of these are solutions because if I substitute the first number for the x value, the second number for the y value, I get a true statement. Like for the last one, minus 2 plus 7 equals 5 is a true statement. So I could actually show you the infinitely many solutions displayed on a graph. So, of course, each of these solutions I could plot on the Cartesian plane as a point. So the first one was x equals 0, y equals 5. So that one's there. And then x equals 5, y equals 0, that point there. X equals 4, y equals 1 is about there. X equals minus 2, y equals 7 up here. So it turns out if I plot each of the solutions as points, they will lie in a straight line. So this here is the line x plus y equals 5, and you should view each point on this line is a solution to this equation, an x and y value that if substituted satisfy this equation. What about x minus y equals 3? Well, hopefully you recognize that if I were to graph this, it is also a straight line. And we learned how to graph this. We would use the Xy Intercept Method. So what we would do is let y equals 0 to find the x-intercept. So if y equals 0 here, x equals 3. So the x-intercept of this line is 3. And then if x equals 0, I'd get minus y equals 3, y equals minus 3. The y-intercept of this line here is minus 3. So that is the y-intercept, and if I wanted to graph it, I would just join up those points. But finding those points means I've just found solutions to this equation here. So if x equals 3, y equals 0, so that's one possible solution. Another possible solution is x equals 0, y equals minus 3. So both of these solve the equation. 3 minus 0 equals 3, that's a true statement. 0 minus minus 3 equals 3. That's a true statement. And there'd be infinitely many solutions to this equation as well. So we could have, another solution, say x equals 6, y equals 3. We could have x equals 4, y equals 1. We could have, a negative value for x. We could have x equals minus 2. Then y would actually be minus 5. And so on. There'd be infinitely many solutions to this equation and to this equation. It turns out, though, that there will be one special solution. That's a solution to this equation, but also a solution to this equation. And that's this solution here, 4, 1. X equals 4, y equals 1 solves this equation and this equation at the same time. So let's draw the graph of x minus y equals 3. So once again, each point along this line is a solution to x minus y equals 3. So notice both of them go through this point 4, 1. The solution to both equations is the point of intersection of the two lines. That's what we're finding when we're solving simultaneous equations. But the thing is, what if the solution was something like x equals 0.725, y equals minus 1.3? You wouldn't be able to see this by graphing it. So we need to have another method. So now what we're going to do is we're going to look at solving equations like this without drawing a graph. And the method we use is called elimination. So please pause and copy this down if you need. So the idea with elimination is we want to eliminate, get rid of one of the variables, either x or y. The problem is both these equations have 2 variables. We don't know how to solve those well. We know how to solve equations that have one variable, so if we get rid of the x's or the y's, we'll only have one equation, one variable we know how to solve. So what we're going to do is we're going to either add or subtract the 2 equations. So let's say I add together these 2 equations. So let's add everything in components. So x plus x gives me 2x. Y plus negative y actually gives me 0. 5 plus 3 gives me 8. So if I add together these 2 equations, I get 2x equals 8. This red equation is easy to solve. We've solved it a million times before. I just divide each side by 2 and I get x equals 4. So that's the x value of the solution. Now I need to find the y value of the solution. So I take x equals 4 and I substitute it into either equation, doesn't matter. So let's pick the top one. So if I substitute it into the top, I have x plus y equals 5. I'm going to substitute x for 4. Once again, this is an easy equation to solve. Y equals 1. My solution, x equals 4, y equals 1. So note, this is the same solution I had on the previous slide. I just managed to figure this out now without drawing a graph, because as I said, drawing graphs can be inaccurate and they can take a long time. So notice what I did here was adding the 2 equations, I got rid of the y's, and that allowed me to find the solution. So let's look at another example. So let's say I wanted to solve this equation and this equation simultaneously. I want to find a solution of this equation that's also a solution to this equation. I want to find something that solves both equations at the same time. I could graph this line and graph this line. The answer would be their point of intersection. But as I just said, graphing takes a while and it can be inaccurate. So instead, I'm going to use the elimination method. I want to eliminate one of the variables. Let's try the trick that we tried over here. Let's add together the 2 equations. So if I do that, I get 3x plus 4x is 7x, 2y plus 2y is 4y, 42 plus 50 is 92. I didn't actually eliminate the x's or the y's. This equation here is no easier to solve than either of those. So this time, adding didn't actually work. It didn't really help. But what about, instead of this, I'm actually going to subtract the 2 equations. So how about I subtract this bottom equation from the top? So I go 3x minus 4x, it gives me minus x or minus 1x. 2y minus 2y gives me 0. 42 minus 50 gives me minus 8. Now I've got an equation that's easy to solve. Minus x equals minus 8. I just get x equals 8. So I'm not done yet. I found the x value but not the y value. So to find the y value, I substitute into either equation. I'm going to choose this top one here. So I get 3 times 8, 3x, plus 2y equals 42. You know how to solve this. Subtract 24, divide by 2, you get y equals 9. So the solution here is x equals 8, y equals 9. In this equation, adding together the 2 equations eliminated the y's. This time, subtracting the 2 equations eliminated the y's. So how do I know whether to add or to subtract? So this tells you how we go about this. So when we have 2 simultaneous equations, the variable we eliminate, that we get rid of, is the one that has the same coefficient in both equations. So here, y had a 1 and a minus 1 in both equations. So both of them kind of had a 1 in front of it. Here, both y's had a 2 in front of it. That's why we eliminated the y's here. In this first one, we could have eliminated the x's or the y's. We eliminated the y's because there's a +1 and a -1. So if they both have the same sign, you subtract. So here, both of these are positive 2. So we eliminate y because it has a 2 in front of it in both equations. We subtract because it's positive. In this one, however, when we're eliminating the y's, one's a positive, one's a negative. So that's why we added here and subtracted here. That is how you eliminate one of the variables. All right, let's look at a few questions that are a little more challenging now. So let's say I want to solve these two equations simultaneously. Once again, I want to find something that solves both equations at the same time, and I want to do it without graphing. Now, what I said on the previous slides, we eliminate the variable, the x or the y, that has the same number in front of it in both equations. But this is a problem. Neither x nor y has the same number in front of in both equations. When that happens, you need to multiply one or both equations. So I'm going to multiply this bottom equation by 3. That will make the x have a 3 in front of it, and then the x's will have the same coefficient. See, as it stands, before I multiply by 3, adding together these two equations, subtracting one from the other will not be helpful. But let's multiply the bottom equation by 3. That means I multiply everything by 3. X by 3, negative 5y by 3, and negative 23 by 3. So I'm going to leave the first equation alone. Multiplying the bottom by 3, I multiply x by 3, minus 5y by 3, and minus 23 by 3. Now I'm going to solve these two equations simultaneously. I can do that because the x has the same number in front of it in both equations. So because it's positive in both, I'm going to subtract. So I go 3x minus 3x is 0. This time I'm eliminating the x's. Minus 4y minus 15y. So it's minus 4y plus 15y. You can put that on your calculator if you want. Minus 4 plus 15 gives me 11. So I get 11y equals, so 8 minus 69. 8 plus 69 gives 77. Now I just divide each side by 11. I get y equals 7. I'm not done. I need to find the value of x. So I have 3x. I'm going to substitute this into the top equation here. 3x minus 4 times y. 4y is 28. 4 times 7 equals 8. Add 28 to both sides and divide each side by 3. So the solution here is x equals 12, y equals 7. So now we're going to look at an example where you need to multiply both equations. So let's have a go at solving these two equations simultaneously. Once again, I want to find something that is a solution to this one and also a solution to this one. Again, I have a problem. Neither x's nor y's have the same coefficient in both equations. So I'm going to need to this time multiply both equations. If I multiply this top equation by 2, then the coefficient of x will be 6. If I multiply the bottom equation by 3, then this will become a minus 6x. The x's will have the same coefficient in both equations, then I can eliminate the x's. So once again, remember, when I'm multiplying an equation by a number, I need to multiply everything in the equation. So the top equation becomes 3x times 2 minus 5y times 2 and 0 times 2. Bottom equation, minus 2x times 3, 6y times 3, and then 16 times 3. Now the x's have the same coefficient in both equations, so I can add or subtract to get rid of the x's. Now because I have a positive and a negative, different signs means I'm going to add together the two equations. So 6x plus negative 6x is 0. Minus 10y plus 18y gives me 8y. And then 0 plus 48 gives me 48. So dividing each side by 8, I get y equals 6. I'm not done. I need to find x. So I'm going to substitute this into the original equation. I get 3x minus 5 times y equals 0. Add 30 to both sides. Divide by 3. Get x equals 10. So the solution to both equations is 10, 6. This solves this equation and also this equation at the same time. All right, the very last thing I need to do now is show you a couple of word problems. So let's look at solving worded problems using simultaneous equations, and always follow these rules here. So you start by defining the variable. You let x equal one of the things you're trying to find and y equal the other you're trying to find. Then you form two equations and you solve them like normal simultaneous equations. So let's look at this question here. Sum of two numbers is 28, difference is 4. What are the two numbers? So what we have are two numbers, a larger and a smaller number. So I'm going to let x equal one of those. I'm just going to let x equal the larger number, and I'm going to let y equal the smaller number. So that's what I mean by defining your variables. Step 1 is done. Now I need to form two equations. So the first bit of information says the sum of the two numbers is 28. So if I add together the two numbers, I get 28. That's one equation. The second one says the difference is 4. So that means larger number minus smaller number equals 4. Now that I've got the two equations, the hard work is done. I just solved them exactly like I did in previous slides. This one's easy because both x and y have the same coefficients. So I could just, for example, add the two equations to get rid of the y's. X plus x is 2x. Y plus negative y is 0. 28 plus 4 is 32. Divide each side by 2, I get x equals 16. So that, of course, means y equals 12, because 16 plus 12 is 28. So I should write a worded answer to a worded problem. So I've just found out the larger number is 16, the smaller number is 12, so the two numbers are 16 and 12. 16 plus 12 equals 28, 16 minus 12 equals 4. All right, thank you so much for tuning into this video. This has been the luckiest maths teacher in the world. Have a great day.